Okay, guys, welcome back to the Wonderverse. I am the greatest teacher there is, the greatest teacher there was, and the greatest there ever will be, aka Marshall D. Teach. And we are continuing with the topic Laplace Transform. Now, where were we? We said the Laplace of when you say f of t is a, what is going to be the Laplace? We said it's a over s, right? What is the Laplace of e to the negative at, right? We said it's 1 over s minus a. So now we are about to start finding the Laplace of things like sine at, cos at, but we are going to start with sine at. Now there's something I want us to understand. It's a concept I want us to understand, and it's called complex numbers. In complex number, there is a concept called Euler's formula. Okay, let me show you. Watch this. We say now, this is called Euler's formula in complex number. This is called what? Euler's formula in complex number. Now, there's something I want us to understand. To be able to solve for the Laplace transform of sine at and cos at, you have to know how to manipulate this. This is equivalent to saying, so this now, in terms of Euler's formula, is equivalent to saying Laplace of sine theta. It's equivalent to saying Laplace of sine theta, right? So it means theta is equal to 80. We are going to be assuming that theta is equal to 80. We are also going to be assuming that theta is equal to negative 80. Now, don't start trying to understand why. I'll show you why very soon. You're going to understand how this thing works. So, write somewhere. Assume theta is equal to 80, and let's move forward. Now, the first thing you're going to have this e to the ai at is equal to cos 80 plus I sine 80, right? This is what you're going to be having. Now, this is what you're going to be having. And then there's something you should also do, which is assume theta is equal to negative 80. Now, this is assumption 1. So this is our first assumption, and this is our first equation. Now, we are going to go to the second equation. We are going to create a second equation, and it goes like this. We are going to say this. Since theta is equal to negative 80, we are going to have e to the power of minus I 80 is equal to what? Is equal to what? It's going to be equal to cos of negative 80 plus I sine of negative 80. Now, it's not going to end here. It's not going to end here. Now, see, cos is even and sine is odd. What does that mean? When we say cos is even and sine is odd, it means that cos of minus x is equal to cos of x, but sine of minus x is equal to negative sine x. So this means even. This means odd. Are we following? This means something is even and this means something is odd. So let's move forward. Okay? So we still have our equation 1. Let's find out equation 2. So from this now, what can we say? What can we say e to the power negative I80 is? What can we say it is? So we are going to say cos of minus 80 is the same as cos of 80, right? Because of it is even. So we are just going to say cos of 80 then plus I sine negative 80. Because of sine is odd, we are going to have minus sine 80, right? We are going to have minus I sine 80. So we are going to have minus I sine of 80. So this is our second formula. Now we are going to be using these formulas to play. We are going to be using these formulas to play. That is going to be our equation 2. We are going to be using them to play and to derive the Laplace of sin AT and the Laplace of cos AT. Stay tuned. Okay, so just now we came to these conclusions, right? We came to these two conclusions that e to the negative IAT is going to give you this, and e to the IAT is going to give you this, right? So now we want to find the Laplace of sin AT. How do we manipulate these two in such a way? How do we manipulate equation 1 and equation 2 in such a way that we are going to eliminate everything cos? How do we manipulate it in such a way that we are going to eliminate everything cos? Look at it, look at it. Look at it. How do we do that? I believe the best way is to add this equation to this one. So by the time we do minus I sin AT plus I sin AT is going to give us 0, right? And so, okay, no, is to minus these two. Is to minus these two equations. What I just said now is going to be for cos, to eliminate sine. But in this one, we want to eliminate cos. We want to eliminate cos. So we are going to minus these two equations. So if we go like this, e to the negative IAT minus e to the IAT, what are we going to have? Cos AT is going to minus cos AT, right? So that is going to be 0, right? So cos has gone. So minus I sin AT plus I sin AT. Sorry, minus I sin AT minus I sin AT. Why am I biting my tongue? In whole Marshall do teach. We are going to have this minus 2I sine of what? AT. So this is what we have. This is what we have. Now, what are we going to do? We are going to make sine AT the subject formula, so we can start the Laplace transform. What are we going to have? We are then going to have sine AT. We are going to put it on our left hand side so it will look more official and tantalizing. It's going to be e power negative IAT minus e power IAT all over what? So you know it's a that I said here. All over what? 2i. That's negative 2i. But let's twist this. I don't want to see this negative here. I don't like seeing that negative there. So we are going to say sine AT. Let's take the minus to the top. Let's take the minus to the top. This will become positive and this will become negative, right? So it will now be e to the IAT minus e to the negative IAT all over what? 2i. All over 2i. This is our formula. This is our formula for sine AT. This is what we are going to be using to solve from now. This is what we are going to be using to solve. Let me put you well so you will not say that you don't understand. Okay, let's move forward. Let's move forward. Okay, now sine AT is equal to this, right? We've proven that sine AT is equal to this. So now let's take the Laplace transform of sine AT using this. Firstly, we are going to bring out this 1 over 2i. We are going to scrap it out first. Let's be seeing what we are doing. 1 over 2i. Let's say this. Oh God. So Laplace transform. We are going to be saying Laplace transform of this. Who remembers what our Laplace transform looks like? This is what is going to be, right? So what is our next step? We are taking Laplace of this, but we are going to bring out 2i as a constant. So Laplace of sine AT is going to be this. 1 over 2i. This is a constant. I'm scrapping it out for now. I want to bring it out so I can make everything easier. Then I'm now going to take integral from infinity to 0. I want to share this into 2. This is now e to the power of IAT and e to the power of minus IAT, right? E to the power IAT minus e to the power of minus IAT, because I brought out 2i outside. I brought out 1 over 2i outside. So I now have this. e to the power of minus st times e to the power of what? IAT. I hope you're seeing what I'm writing. This is S and this is IAT. This is ST and this is minus, I'm sorry, this is IAT. Minus integral from infinity to 0. Mind you, I've already brought out 1 over 2i, right? I've already brought out 1 over 2i. So this is now e to the power minus st multiplied by what? Negative IAT. Right? dt. This is dt. This is dt. Mind you, we are differentiating. Sorry, we are integrating with respect to t, right? So you always have to mind putting your dt there. So now what do we have next? What do we have? We have to simplify this. So 1 over 2i remains outside. And then we now have integral from infinity, from 0 to infinity, e to the power. Remember, anytime you're doing this, you have to, I've forgotten, what is that term again? What is that term? But just know that your s has to be in front. Your s always has to be in front. So we have to do something like this. If we are bringing our s to the front, you cannot now say a minus s, right? You can't do that. You can't say a minus s in Laplace transform. S has to be in front, so you have to say s minus a. That is Laplace transform for you. So we are going to bring down minus. If we bring down minus, what happens? We are going to have s. Oh God, my matter. We are going to have s minus a instead. S minus a, s minus ia, yes. S minus ia t outside. That's what we are going to have here in t. So this is what is going to be simplified to. Then on this part, it's going to be simplified to from 0 to infinity, e to the power of, if we bring down minus, what are we going to have? If we bring down minus, we are going to have s plus ia, oh God, s plus ia and t being outside. This is s plus ia and t is just outside, right? And the minus is sitting outside here. The minus is sitting outside there. So that is what is simplified to at this point. That is what is simplified to. Let's move forward. So now we shall integrate these two. When we integrate, what do we have? I don't know what is wrong with this my matter. We have this one is going to become, you already know how to integrate. I hope we all know how to integrate. I hope we all know how to integrate exponential. When you have integral of exponential, it's basically, when you have integral of this, you're going to have that with respect to integral of this. You're going to have this e power minus xt all over x plus c. So mind you, this is what you're going to have. If you have this is what you're going to have. Mind you, note that this is what you're going to have. So let's move forward. So applying that here, what are we going to have? We are going to have e to the minus s minus ia t all over minus s minus ia. That is what we are going to have. That is what we are going to have. Now on this part, what are we going to have? Minus, okay, we are going to say this one is from infinity to 0. Sorry, from 0 to infinity. Why do I keep displacing it? Minus, this one is now going to be what? Mind you, everything is in brackets. Everything is in brackets. Everything is in a huge bracket, showing that this 1 over 2i applies to both of them. This one, if you integrate it, this is what you're going to have. E to the power minus s plus ia t all over what? All over s plus ia minus s plus ia, sorry. Sorry, this t is not meant to be here. This t is not meant to be here. Wait, sorry, the t is meant to be there. What am I saying? What am I saying? T. Okay, so this is what we have. 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 This grand formula is what we have. So now we are going to move forward. We are going to solve this. Okay, so I had to rewrite that so we can see it more clearly. So if we look at this now, we have to check both limits when t is infinity and when t is 0, right? You have to check both limits when t is infinity and when t is 0. So when t is infinity, don't forget, we are now going to have e to the power of infinity, right? E to the power of infinity. And what do we say is the power e to the power of infinity? What is it going to give? It's going to give you 0. It's going to give you 0. So here we are going to have 1 over 2i all into brackets. This first bracket, what are we going to have? E power negative sign blah, blah, blah. This is basically e to the power of 0 because of when you put t as infinity, you're going to have e to the power of infinity, which is 0, right? E to the power of infinity, which is 0. So we are going to have 0 minus, we are now going to have here 0 here as t, 0 as your t. You're going to have e to the power of 0, which is 1. So you're going to have 1 over minus s minus ia, right? This is what you're going to have in the first bracket. Now in the second bracket, what are you going to have? Infinity again is your power, so you already know automatically another 0, right? Then as if when 0 is here, you're going to have 1 again, right? So you're going to have this 1 over minus s plus ia. So this minus is plus automatically, right? So we have plus inside the bracket. So at the end of the day, we are going to have 1 over 2i. Mind you, the entire bracket is still there. So we are going to have 1 over 2i all into brackets 1 over s minus ia minus 1 over s plus ia. Did we get it? I'm sure we did. Did we get it? I'm sure we did. So we are going to move forward from here. So now taking the LCM of this, what are we going to have? We are going to have 1 over 2i all into brackets. Two of them, we have s minus ia and s plus ia. So on top, we are going to have s plus ia here, right? Minus s minus ia, right? That's what we are on now. That's what we are on now. So let's move forward. What is he going to give you in the end? 1 over 2i all into brackets. S minus s is going to give you what? S minus s is going to give you 0, right? Then ia minus ia is going to give you 2ia. 2ia. So we have 2ia at the top. Then at the bottom, what do we have? What do we have? S times s, we are going to have s squared. S times ia, we are going to have plus sia. Minus ia times s, we are going to have minus sia. And then minus ia times plus ia, we are going to have minus I squared a squared, right? So this is what we are going to have. This is what we are going to have. Now, this is going to cancel this. These 2i outside has finally left us. It has finally left us behind. So now we have a all over s squared. And then this is going to disappear. SIA minus SIA is going to disappear, right? Minus I squared. I squared is 1. I squared is 1. It's like saying square root of minus 1 times square root of minus 1, which is basically minus 1, right? This is going to give us minus 1. Okay, yes, it's minus 1. This is minus 1. Hold on. Yes, this is minus 1. So we are going to have a all over s squared minus square root of minus 1 squared times a squared. This is what we have right now. So in the end, watch what is going to happen. Watch what is going to happen. We are now going to have a, I hope you're watching. We are now going to have a all over s squared minus 1 times a squared. So which is a all over s squared plus a squared. Now this is our formula. This is the Laplace transform of sine 80. This is the Laplace transform of sine 80. So we have Laplace of sine 80 is equal to a all over s squared plus a squared. I hope we understood that. This is a very, very simple derivation, right? So we are going to put it there. A all over s squared plus a squared. That is our sine 80. Now we are going to move over to cos 80. Okay, I want us to recall our formula. What did we say in our previous formula? We said e to the negative I80 is what? We said is cos 80 minus sine 80, right? Then what did we say is e power I80? We said it's cos 80 plus sine 80, right? So now the question is this: how do we eliminate sine? How do we eliminate sine and have only cos? How do we eliminate sine and have only cos? Before I exposed it in the previous video, in these two equations, if you add two of them, if you add these two equations, if you add them to each other, you're going to have minus sine 80 plus sine 80, which is minus sine 80 plus sine 80. So sine 80 is going to disappear, right? Sine 80 is going to disappear, and then we are now going to have 2 cos 80. So if we say e to the negative I80 plus e to the I80, we are going to have 2 cos 80, right? This is what we are going to have, and this is where the derivation begins for us. This is where the derivation begins for us. So let's move on. Now we have that officially cos 80 is going to be what? We have officially that cos 80 is going to be what? E to the negative I80 plus e to the I80 all over what? All over 2. This is what we are going to have, right? Let's move forward with the derivation. So now remember that the Laplace transform of anything is basically e to the negative st dot f of t, right? dt, integral from infinity to 0. So what is it going to be in this case? Laplace of cos 80 is going to give us what? Integral from 0 to infinity e to the negative st multiplied by cos 80 dt. And since this is our cos 80, what are we going to do? First step is to bring out 1 over 2. Shift 1 over 2 outside. Shift 1 over 2 outside in from the major brackets. We are going to shift 1 over 2 outside from the major brackets. And what is the first thing we are going to do? We are going to take Laplace of this and Laplace of this individually, right? So here we are going to have Laplace from 0 to infinity of e to the negative st dot e to the negative I80, e to the negative I80 plus dt. Sorry, always remember to add your dt, else they can fail you for technicalities. Plus e to the negative st, remember from 0 to infinity, right? Dot e to the I80 dot e to the I80, right? dt. So that is what you have. Let's move forward. And so if we are going to do this, we are going to see how we are going to simplify it here. See how we are going to simplify this. We are going to say minus outside. So what is going to be inside here? S plus IA multiplied by t. The t, right? That is for the first bracket. On the second bracket, integral from 0 to infinity. E to the power of, if we bring down minus, what are we going to have? S minus IA multiplied by t, dt, right? So this is what we are going to have. Let's take it a step forward. Let's take it a step further. Okay, taking it a step further, what are we going to have? What are we going to have? So we are going to have E, integrating the first one, we are going to have E to the negative S plus IA all into T all over negative S plus IA. And this is going to be within the limit of 0 to infinity, right? Plus, we are going to have, remember 1 over 2 is still sitting outside, 1 over 2 is still sitting pretty outside, plus E to the what? E to the negative S minus IA multiplied by T all over negative S minus IA, yes. This also on a range of 0 to infinity. Close everything. This is what we have now. Okay, so let's move forward. We are going to have 1 over 2 outside. Okay, so now infinity, when infinity attacks this, what are you going to have? E to the power of 0. So we have 0 minus to the power of, when t is 0, what are we going to have? E to the power of 0 is what? E to the power of 0 is what? Sorry, the last time I said e to the power of infinity is going to give us 0. So the first one is 0. So e to the power of 0 is going to give us what? 1. So we are going to have 1 over negative S plus IA. That is going to be our first one. Plus, what is going to be the second one? To the power of infinity, we are going to have 0 again, 0 as well. Minus, to the power of 0, we are going to have 1. So we are going to have 1 all over minus S minus IA, right? So what is going to be the next thing to do? What is going to be the next thing to do? The next thing to do will be to say 1 over 2 sitting outside. We are then going to have inside the bracket 1 over S plus IA plus minus is what? Plus, right? All over S minus IA. This is what we have. This is what we have. So what is our final answer going to be? Remember, the last one we rationalized. So here we are going to rationalize again. We are going to put 1 over 2 outside. Then, sorry, we took the LCM, not necessarily rationalization. We took the LCM, not rationalization. I used the wrong terminology there. So, taking the LCM, we are going to have S plus IA into S minus IA. And we are going to have S minus IA plus S plus IA. So we are going to have 1 over 2 multiplied by S plus S is 2S minus IA plus IA is 0 all over S times S is S squared, S minus IAS plus IAS. That is when you do IAS, IA times S is going to give you plus IAS. And then minus what? Minus I squared A squared. That is what we have at this point, right? That is what we have at this point. Let's move forward. So we are now going to have 2 is going to cancel 2. As 2 cancels 2, we have only S on top. So S all over S squared plus what? this IAS minus IAS plus IAS is 0. So then this one is going to give us minus, I told you I all squared is the same thing as saying square root of minus 1 times square root of minus 1 is going to give you minus 1. So we have minus 1 multiplied by a squared. Multiplied by a squared, right? So what is going to be our final answer? What is going to be our final answer? So our final answer is s all over s squared plus a squared. Our final answer is s all over s squared plus a squared. So here we can finally have our s all over s squared plus a squared. And that is how to find the Laplace of sine 80 and the Laplace of cos 80. Simple, right? Simple. Catch you guys later. We are going to find how to find the Laplace transform of sine 80 and cos 80. Thank you.